Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 113. Minimum edge reversal so every node is reachable. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem. This one I actually talk about a little bit during the live portion as well, but the key, but I'm not gonna lie, I talk about the way that I solve this problem and maybe some optimizations and how to kind of reach the solution, right? Because the solution is interesting for sure, and it's important to understand the solution, of course. But for me, I want to talk in general more about how to come up with the solution, right? Because I think that process is what trips a lot of people up, especially when it comes to doing a hard problem in Q4. Maybe not this particular one, but in general, because that's where pattern matching kind of starts failing you, right? This is the difficulty where that starts happening. And for me, yeah, I'm not. I'm going to start by saying that I kind of did the thing that I preach against a lot, and what I preach against a lot is kind of using heavy machinery when it's not necessary. And I started out with this problem thinking that is this advanced, but I mean, not too advanced per se, but a tricky technique to implement, at least for me, called tree rerouting, right? Meaning you calculate the answer for one node and then you reroute the whole node to calculate it. I end up taking, I think this shows up as 9 minutes, but maybe closer to like 15 minutes on this problem. Some of it because I was tilted on Q3, but also just because there was a lot of confusion near the end. I definitely felt, especially in retrospect, I could have done better with this particular problem with respect to timing, but because I feel like I just wasn't confident about it because I didn't, yeah. And the thing that I could have done more is spend more time in the beginning really thinking about what to do versus just like, thinking about rerouting. But it turns out this problem is really, without going over rerouting, this problem actually turned out to have a very nice property that you can exploit, and which is one that I wish I found earlier. I did come out with it later, and that's what my solution is roughly going to be. But yeah, let me pull up. That's not even a word. Let me pull up the drawing pad. Hang on. Did I lose my pen? Oh no, there it is. So this one, you have a tree, right? And very often, I mean, I don't know if there's a case that I can think about off my head. With these problems, the way to think about it is, well, okay, well, I think I missed a step, which is saying, and this doesn't have to be binary, and this is actually also, is directed. The way that I think about the directedness, to be honest, is just to add a cost to the node, right? Or to the edge, which we'll show in a little bit. But assuming that you can do n squared, because if you could do n squared, this is very trivial. You just run this n times, and I say this, but Leetcode do those problems from time to time. So it's not out of the question, but definitely look at the constraints, right? But let's say you cannot do this in linear time, you cannot do this in quadratic time, and you want to do this in either linear or maybe n log n or something like this, which usually will be fast enough. What you need to do, of course, is at least solve this problem once. And what I mean by that is you have to solve it for one node, right? Because here you have to solve it for every node, but you have to solve it for at least one node because you can't really skip around it. The idea is that, I guess there is maybe a divide and conquer solution, but still, most of the time you have to solve it with one node. And so here, it doesn't really matter which one. You have to do it arbitrarily, or you can do it arbitrarily, so it doesn't really matter. I always start with just node 0. So let's say we root a tree at the top, by definition. This one, right? I'm just changing colors real quick. And here we calculate the answer for number of reverse edges, as they call it, which is the number of nodes that go across the edges. And you could calculate this with a regular depth first search. Makes sense, right? Yeah. And the way that I did it during the contest is a little bit clunky because like I said, I was trying to use the rerouting technique, so this may not make sense. The code may not make sense, but hopefully the algo does, and you can implement it a little cleaner than I did. But yeah, but basically this is just depth first search. So then now this is what, 1, 2, 3, 4. So the answer here is 4, right? So now we calculate the answer is 4. What happens? Well, now we need a second depth first search to calculate the rest of the answers. And it turns out that there's a very nice property in that when you make a movement on the depth first search, what happens? Well, obviously only one edge change, right? Because only one edge change, you can just do the math on that delta. Or you can think, another way to visualize it is frontiers, but the answer is always going to change only by one edge, because only one edge change, right? So if the answer for this is 4, the answer is only going to be either 3 or 5. I guess it has to be either 3 or 5. It can't even stay 4 because... Oh, actually, I'm wrong. It depends on how you... No, I'm wrong. Because I was thinking still about the delta parts, but... Wait, is that true? I don't know. Either way, you have to do it. You have to do the delta with respect to the edge that you change, right? Meaning that and this is just a logic thing, right? Going from the red root to now, let's say the blue is now root. What happens? Well, this component doesn't change. This component doesn't change. The only thing that changes is the edge, as we talked about. So then now, in the perspective of this node, what is this edge, right, that we looked at? I'm going to change the colors again, even though maybe it doesn't make sense this time. Like, what is the impact of this, right? Well, going from here, we can see that this is going up. So going here, we know that one of the 4 is this edge, right? So that means that here, now for this edge, now there's only 3, right? Because now, from the perspective of this edge, this is going the right direction. And that's basically the idea. And then now you also do the same thing going down. So then let's say this is the next node. Because this is the right node, then now this goes back to 4 because in the perspective of this new node, this edge that we just DFS is going to be in the wrong direction. So that's basically the idea for this problem. And once you kind of realize this and visualize it out in a good way, it should be pretty clean. Yeah. Like I said, I wrote this in a little bit of a messy, weird way, just because yeah, just because like I thought I was trying to do rerouting. But yeah. The way that I would rewrite it is, let me think about this, is actually, let me rewrite it with you at home. What I would do is just calculate it for answer of 0, right? So total of 0 is equal to this thing. And here we don't even, we have, let's just say count is equal to 0. And then this part of the code is just the first of the recursion. We count the weight of the edge and then the sum of all the subtree, right? This part should be very, this is a way, if this was just this problem, you don't have to do it one node. It is probably like a very easy medium at the hardest. So I'm not going to explain this part. I fully expect everyone to get this. And here, I will go back to set up the edge to say that I did add a rate of 1 for going, basically I count the number of in the opposite direction, I added a weight of 1. So it's almost like the cost of going that way is 1, and the cost of going the same way is 0 if you're going upstream or downstream or whatever, right? So you can rewrite this part as this, and this is just the sum of the edges, some of the wrong edges, right? So there's this, and then here, yeah, the way that I would write this is actually, yeah. Oh, maybe this. It doesn't really. Yeah, I mean, you could write this in a number of ways, but maybe parent sum. Right. And that's basically it, really. Hopefully, that I'm not lying. Whoops. Where did I miss D? Oh, this D. No, it doesn't really matter because it's not -1. Right. So yeah. Again, let me rewrite this down here. This is just to calculate the sum of the subtrees, and here this is saying let's calculate it in the let's recursively calculate. Yeah, let's recursively calculate what is the change to this node, and on every node we just pass in the weight. And like we said, this is just, I mean, this looks a little bit cryptic, to be honest. This part is just saying that if this is not the root node, but this is saying that if the node is 0, it just sets up the direction. And as we showed in the visualization, either we just go up 1 or down 1, depending on, you know, the edge, like if the edge gets flipped or not. So yeah, and in total, and then you just kind of save it down somewhere, and then we can return total. Yeah. So what's the complexity here? This is going to be linear time, linear space. This is also a tree, so linear is v plus y, but y is also just v minus 1, right? So yeah, so this is linear. Yeah, that's all I have for this one. Let me know if you have any questions. Yeah, you could watch me solve it live during the contest next. I was tilted a little bit for the first 5 minutes or so, so I was just so not focused, but you can maybe skip that a little bit. So yeah, yeah. See ya. Skip ahead, and if it still doesn't work, it is what it is. Minimum attributes so that every node is reachable. There's a Alright, fine, I have to focus. Alright, focus. So where would the edge becomes a directed edge control. The minimum of edge, so that is. So I have to make this. Oh, starting from I. Okay. I don't even. Forbidden. Yep. This is, you know, can't even get an actual time. But I guess, I mean, I'm recording it, so, but it's just silly. Okay. So basically, we're trying to get the number of uphill things. 10 to the 5th is n, right? So it's just recursion, probably. I just have to think about it, and then not be able to submit it afterwards. Okay, so let's say we go recursion, and then we just count, right? What a disaster, but okay. I'm not even focused. I'm so like out of tilt these days. Because it's just There's not another contest going on, right? Alright, anyway. Let's say we do a version, then we calculate it for, well, we calculate for the answer for 0, right? So calculate it for the answer 0, and then how do I get from 1? Is this just a rerouting? No, for each edge, I feel like I always go to rerouting as a solution, but it would be funny if I'm having issues with the Leetcode. Is my internet okay? I don't know. Seems like it's okay. It should be Leetcode. All right. I'm still not focused, so tilted on this. Okay, let's just write diff code. Okay, let's say we're recursion. Do we always do the rerouting? Right. Okay, let's say we do a recursion. Calculate for 0. That's easy. And then going the other way. Going down should be easy because it's just the math counting that, right? Is that true? To the first search? It should be faster about this. So we calculate, and then now you pass in the number of things. Okay, that's good. And then that also has the answer, but then now you have to pass in the root of the other ones. Okay, I mean, okay, I mean, this is doable. I don't know. Let's just some u to v, right? Something like that, and something like that. Okay, so then now what we want to do is okay, we want to store the things, right? So then now if it's going the wrong direction, it's -1. So if w is -1, then what? Maybe I'll rewrite this as cost. So then now total of now it should return the number of bad nodes, say. So then total of node something like that, right? I can't even run this, can't I? I was gonna just like run it for to see. Oh, there you go. All right, maybe I could submit it now. Okay, so I mean, we had so much more time, but okay. I was gonna say we can run this to kind of see an example to see how my code is doing, but I guess actually we maybe came back just in time, even if it kind of tilted me for like a couple of minutes. I don't know how long it took, but okay. So from 0, it goes to the wrong direction twice. Okay, that is right. Right. Okay. Okay, and then now we need a TFS2. Okay, so this is the subtree, so then now you have to get it from the parent. Okay. This rerouting is always a little bit a sketch for me. So it's the number of on path of the parent. No, you have to do it first, don't you? Okay. So this is the number of wrong paths on the parent. Whatever. Minus itself, because now it double counted twice. No, it's just the number of wrong paths of the parent, not including itself. The direction. Maybe I pass this in or something. Is that right? Something like this, but I'm just like hand wavy a little bit on it, so I don't know. If we're thinking of 0 is 2, it goes to 2. 2 is going to be equal to 2 minus 1 plus, oh, this is minus maybe. Alright, well, that is very wrong. No, you have to, oh, that path considers that already. But, this is also very wrong. Right. So 0 is going to be 2. So then 2 is going to be 2 minus 1 minus the thing, which is 0, which is right. Oh, I'm looking at the wrong node, that's why. Okay. Okay. So 2 is going to be the root, so that's 2 minus itself, which is 1, minus, it's 2 minus 1, so that's 1, right? Okay. That doesn't make sense, is it? Okay, so the number of wrong edge nodes is going to be this doesn't, what am I doing? Number of wrong nodes from the parent. Is this right? Right for this one, but it's not right for the first one. What am I doing? Q3 tilted me so much. Okay, so at this graph, so we have 0, we calculate it's going to be 1 path, and then now we recurse to 2. 2, because we go up the path, it should be fine. We go up the path, so it should be fine. So it should be just this. I should be doing this much faster. I think I set up the edge a little bit weird, that's why. What I want is, I keep on playing with the signs, but what I need was actually something like this, because I'm using 1 and 0. I think that's the difference. Maybe add, I don't know. Maybe not as either. Tell me why. Maybe I need a second total. I think that's the. Okay, from 0. Why am I so slow today? Okay, so 0 is 1, and then you go to 2. It should be minus 1, right? And this is going to be 1, so then this is. Okay, but then now 2 going to 1. 2 going to 1 is the right side, so that means at 1 you actually this parent plus 1, right? So the D doesn't make sense because D is 0. If D something like that, maybe. I think that's what I needed. Okay, fine. Just really, this should have been much quicker, to be frank. Let's give it a submit. Yeah, I mean, I kind of knew what I wanted to do, but I think I was just getting sloppy on it. And I also got tilted on Q3 because of time issues. Like I probably spent 5 minutes just like trying to figure out the server issues. But yeah, overall, of course, overall during thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest and the problems and everything in between. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.